Hi, good morning. My name is Martin, and I want to talk to you about email server testing. And let me start with a simple example. So what is the first thing basically everyone does when they put a web server online these days? Well, many times what you do after it is deployed and online, you check the score on SSL apps. Which is a fine thing, because we can safely claim that SSL Labs has made the internet a safer place, because it's bad for your reputation if you have a bad score there, so people will tell you about it and you will fix it until you have an A, or you're otherwise satisfied with the result. And so this is good in the end because it keeps the web safer, it keeps bad configurations out of the picture. The only drawback is SSL Labs only works with HTTPS websites. Now, the question is, what would you do when you put a different server online that uses TLS somehow? What would you do if you put a web email server online? For example, SMTP, IMAP, POP, whatever. And the answer is, there's no good tool right now that would do a comprehensive report for you like SSL Labs does, and that's a pity because it's not so different as you can imagine. TLS stays TLS wherever it is used, and so the question is, why don't we have a tool like that? Wouldn't it be great to have a tool that not only allows you to test web servers, but also allows you to test SMTP, IMAP, POP, or any other protocol basically that uses TLS? And yeah, it would be great, and that's why I'm here today, because the answer is we are working on something like this. We want to give you a tool that allows you to do all of these things. We haven't came up with a good name yet, so that's our work in progress, or sometimes we just call it the project, and that is to be discussed. That's a bit lengthy here, but I guess more important for you is, what does this thing do? And it's pretty simple. Well, it's very similar to what you do with SSL Labs. You have an HTML interface. There's a form where you put your email host in there. You hit OK, and what you get back is a report. It's not just about TLS, but it's also about DNS records, because that's also important for email. And yeah, that's pretty much it. And how can you use that? Well, we see two typical use cases. Well, first of all, there are private persons. So for them, it might be interesting to see if their email provider, well, if they're, let's say you have an account with Gmail or something, then you want to see if they do things the right way. But I think a more important use case would be similar to how SSL Labs is also used these days. You use this as a tool to validate your setup. Let's say you put an email server online, then you can immediately check if things are going okay for you. And we believe this is a good idea because email security is important, because it's still is one of the major places that an attacker looks for these days. But note that we just care about email servers. We do not have a focus on things like PGP or other client-side technologies, which of course we welcome and endorse, but that's not the focus of our tool. Let's talk about the history of the project a bit, how this all came to be. And like any good project, first of all, there was a proof of concept. And this was sponsored by the Ministry of Economy and Security made in Luxembourg, thanks to them. And the goal was, as always, for a proof of concept, get it running as quickly as possible. And that we did. What were the features of the proof of concept? We tried to show a lot for what was possible in a short time. Well, we did the DNS records, so it fetched DNS records like TLSA, CAA, DMARC, and SPF. And we also did a basic TLS analysis, and because that's the meat of the checks and validations to implement, we took an existing tool called SSL Decoder in order to bootstrap the process. So this gave us a lot of the tests that we could also display to users, and it already offered a JSON interface, so it was easy for us to use this in our own DNS record checks. And this was the architecture of the proof of concept, still pretty simple. The main important thing is there in this gap here, where we forward the TLS analysis to SSL decoder. We do DNS record analysis in our own application, and then we combine the two and show them to the user. So the user fills in a form, hits enter, Rails app does DNS record lookup, forwards TLS analysis to SSL decoder, combines, and shows. So pretty simple. And here are some images of what it was able to do. So here you can see the DNS record displayed for Gmail. Here's another example of the TLS features. So that's very similar to what you know from something like SSL apps. It shows the protocols, cipher suites, certain features, if it's vulnerable against things or not. And finally, the server certificate. So any server sends a certificate chain, and then the chain is listed. Each certificate is analyzed with its details. But as you can already see, all the values are in black, so we didn't do any assessment in the proof of concept. We just listed the details, but didn't do any evaluation. We ran into an interesting problem. Since we wanted to focus on email security and we wanted to cover all the DNS records that are important for email security, of course we also wanted to include DKIM. But the problem is you cannot analyze DKIM without having an actual email. And let's look at a reason for this. If you look up the DNS record in DNS for DKIM, then the string you need to look up is composed of two fixed parts. In the middle, you have the fixed string underscore domain key. And at the end, you have the domain that you're examining. But the problem is this part here in the front. There's a selector. And if you look at the specification, this selector can be anything, basically. And it's even advised to rotate this and to keep it unguessable. So that means we, in our tool, cannot know this value in advance. And so that means basically we cannot look up the record. So how can we solve this problem? Well, we need an actual email sent from that domain that contains a DKIM header. And once we have that email, we can look in the DKIM header and see what the selector value actually is. Once we know the selector value, we can look up the DNS record. And this drawback led into phase 2. There was another big feature, which I'm going to talk afterwards, but this was really one of the issues we wanted to solve in a second phase. We wanted to solve this DKIM issue. And how do we get an email? First, we thought about solutions for this. And I mean, if we need an email from somewhere, then let's just send an email. And we pretty quickly came up with the idea of doing old school web service style, send an email to a service and get an email back. And at first, we thought this was an excuse, but if you think about it, we're talking about email security here. So in the end, I think it really feels natural. So if you want to talk about email security, why not send an actual email? And this, we thought it was a good idea, and phase 2 was again sponsored by the same sponsors, so we could implement this. And it led us to a new problem. If we do send emails, do we really want to go through the whole effort of taking this HTML report that we had and put this in an email? Well, not really. It would have, I mean, it's doable, but it would have taken a lot of time. So what we wanted to have is not sending a report, but we would just send back a reply telling people, okay, your report is ready here at this URL, go there and view it. And then we would just show them the same report that they would see if they go to the HTML web form. The problem with this is if we want to do it that way, if you think it through, it's asynchronous. So we have a request, we produce the result, but the request comes later. So we need to temporarily at least store the result somewhere. We can't put it in a database because that would mean we could collect data and sell this data or whatever. At least we don't want to collect data about our customers. We just want to give you a good tool. And so that's not an option to put it in a database. But I mentioned we just need it temporarily. And so the solution is we cache the result for a given time. Right now it's an hour, and after an hour the result is gone again. And this has also other benefits. We can cache a lot of things. If you think about it, a lot of times you will download the same CRLs, the same intermediate certificates, and all of that stuff. This could also be cached in the future. And for phase 2, we actually had to expand our architecture a bit, mostly because of the email feature. So if you use the web form, everything works as before. As you can see, we integrated the SSL decoder part into the application. SSL decoder is no longer in there, but we have 3 new components. So let's walk it through. If a user decides to send an email, it's received by Node.js frontend, which is using the Node Mailer API, which is a perfect tool for our use case because it can act as an SMTP server, parse the email, and then just create some JSON to forward it using a REST API to the application itself. So to the user, it will look just like any SMTP server, parses the email, sends us the important features, including DKIM, whatever we need. And now this triggers a background job in the application. Background job produces the result, serializes it into JSON, stores it in a cache. Once done, an email is generated containing a link with an unguessable identifier, so nobody can intercept your results. It's just for you, and we send this email using postfix. So postfix is just for outgoing SMTP here. Now user receives the email with the link, will decide to click on the link, open it in a browser or something, and this will trigger a new request to the app, and the app will fetch the cached result, display it as usually. Now, besides these asynchronous features, our other big feature that we wanted to include in the second phase is actually doing some parts of evaluation. In the proof of concept, we just had black text, no judgment. But here in phase 2, we also wanted to give you some indication whether something is good or bad, or if it's fine just as it is. And we added a new phase. So in the proof of concept, we just had these 3 things. So it was a linear process, incoming request. From the request, we collect all the data, and then we present that data to the user. Now in phase 2, we added a second step after the data is collected. We create an internal data structure, and then this internal data structure is evaluated. So it contains all the data that is needed to evaluate it, and we produce another data structure containing the evaluation, and a combination of this is then presented to the user. And this helps us to show different reports. I'm gonna just show you some quick examples of what it would look like. These are just saved pages that I did on some test runs. So first of all, this is a HTTPS test, so not actually email, which is for our own website to show you that we're doing things mostly fine. So many green values, no red values, that's good. And now I want to show you 2 quick examples for emails. For example, yes, Yahoo Mail, that's interesting. Yahoo's website is pretty much top-notch if you look at it on SSLibs, for example, or with our tool. But if you look at the email, you will notice that here, and I'm going to zoom in so you can see that better. If you look at their email setup, they still, I mean, it's debatable if you still want to support RC4 with SHA-1, because some old school clients might need it, but RC4 with MD5 should definitely be banned. And this is the point that we want to make with this tool there. Web server is top-notch because of tools like SSL Labs, because there's public analysis possible, and so this would help also to expose glitches like this. And the question is, now that phase 2 is implemented, where do we want to go in the future? And we have a lot of ideas. First of all, telling you whether something is green, yellow, or red is good. It helps you to fix things, but it is not really well to compare. Like, you can't tell, is this site any better than this? Or are these flaws really that important? To do such to present such a result, we need some form of scoring. Like SSL Labs has its grades, we need to score too. And so what we want to add in phase 3, let's call it, is another phase that takes the evaluation and then puts weights and scores to that, and then outputs these grades or scores to the user. So that's one thing. But if we start doing that, at least if we want to be understandable to people, and then we need to explain ourselves. We need to give a reasoning for why we give certain evaluations, because it's useless if you just tell somebody this is bad. You have to have a reason for why it's bad. But if we need to do this, then this automatically also means we need to provide documentation. And if we provide documentation, why not make it useful for everybody? We can also use this for educational purposes, like having a wiki or something that tells you about what is important in TLS and what are the mistakes or things to watch out for. If you want to use this in a company context, then I could imagine you could use this in automated processes, for example, monitoring, checking every week if my email server is still okay, things like that. And then it's awkward to just have an HTML form as your primary interface. So it would be much better for a company to have a real web API, so you could directly access the results. You have a JSON response, which is documented, and you can evaluate that response and act upon it. So that's certainly something for the future too. Another big thing that I know from personal experience, a lot of companies are a little bit uneasy about using something like SSL Labs because they don't know what they do on their servers with the results. And that's one thing against using it. Another one, maybe even more important, you can only test once the server is online. So if it's bad, the setup, if it's bad, it's already been published online. And that's awkward. You would much rather want to do something where you test the stuff internally in your own network, and only if it's good, then you're gonna publish it. And to do such a thing, you can't use a web application, because the web application itself needs to have public access to that server. So we're thinking about a command line interface, because you could use this anywhere in your private networks, get a report in your private network, and then once you're satisfied with the results, only then you could publish the server and put it online. And yeah, TLS is at the core of every validation in all of the email protocols, also for web servers. But there are a lot more TLS-based protocols, FTP, XMPP, whatever you can imagine that uses TLS. It could all be a part of this. And of course, there are specific things that are only important in specific contexts, but a lot of things and validations and checks are common to all different protocols, so we could use this as a basis. If you look at the tool, I will publish the URL right after the talk here, then you will see it's compared to SSL Labs, there are a lot of things missing, and of course we want to catch up. And since we are also concentrating on DNS records, we also want to catch up with good tools in that sector. Maybe you've heard of MX Toolbox, and so we want to be on par with all of them. The tool itself is open source, and to make it useful, our ultimate goal is to create a community around it, because only then we can evolve it to the point where we see it in the future. But as you know, building a community is hard. It needs sponsors, partnerships. We don't want to be the only ones who decide about things, because we have a domain knowledge, but we can't cover all of the aspects of all possible protocols. So it would be great if we have outside experts who could tell us about other protocols and who can give us their insights. And so all together we can come up with a better tool with more tests, with relevant tests, and ultimately the perfect tool. And that's really the vision that we have for it. So we can build a perfect SSL labs for email if everybody comes together, if we share our knowledge, and if we can set up the tests that everybody is okay with. And the cool thing is, since this is all about TLS mostly, we can not only build the perfect tool for email, but we can really build the perfect tool for TLS as a whole in general. And that's the ultimate vision. Yeah. So thank you. This is the email if you want to test it. It hasn't been battle tested, so please forgive us if anything goes wrong, and we would totally appreciate it if you can send us any things that you noticed or improvements, your thoughts. It's currently secured against crawlers and robots, so we have basic authentication on there. We have a totally secure combination, so username is email, password is secure. And we would really appreciate your feedback. If you want to, please send us an email to contact@emailmate in Luxembourg. Thank you.
Questions, remarks? Yes. So there was one as well. Okay, so we go in order.
Hi, I think this is great. I would really love to have this, and I'm going to spread this in some communities that I know that care about this. A friend of mine actually made a service that tests Dane records. It's on havedane.net. And he was struggling with the idea that you mentioned in sending email, because you need to receive an email. He generates email addresses, and that you have to send. So he makes 3 email addresses, and you send an email to all 3, and the website keeps polling. And once they receive all of the email addresses or not, he can generate the results whether you check Dane or not. So that's another way you could do this. It's open source as well, so if you need any... Sure, yes, of course. Yeah, and thanks for this.
Hi, thank you for your talk. First, I can share this picture on Twitter so everyone can see it. Or not? No, I mean that slide. Okay, and second question, because I did share something about you, I get question on Twitter. Did he spoke about DMARC? DMARC, okay. You can reply? Okay. Okay. Okay.
If it's like that, then yeah, we will just like zoom in.
Yes, he can. It's the question that you did. That you also. Oh, look. This is great.
Okay, well, while we're responding to questions on Twitter, any questions here? Yeah.
Did you have any plans to also add something like history or be able to compare reports? I mean, it's a bit against what you said about privacy. I don't want to keep track of information, but it would make sense to see when something happens, when you improve or...
something changes, right? That's the intent of it. That's actually a pretty good idea. Thank you for that. So yeah, but it's like you said, it's kind of works against the idea of not keeping data. Maybe I could imagine something like having an account. So you can create an account, and that means you want to keep data, and then we could keep the data for people who like to have their data being kept and then access history. Or in the command line version, yeah. I'll take a note of that.
So you keep a track. I mean, if you store it on your server because it's publicly available, you can either encrypt it with the user's password or account's password with the salt, of course, or you can hash it. So even if there is a data leak, only hashes are out and not the real data.
Yeah, I thought about something like that too, but hashes are always... with hashes, you have to think about, in advance, can I create a similar response and then just check by comparing the hash values? Like, for example, if you keep hashes of a social security number, then there are not enough values. You can just iterate through the values, create the hashes, and then look if one of those is in there, then you know that it's the original data. There should be enough randomness in there. Yeah. But also the encrypting idea, that's also good. If we have an account, we can encrypt the data by using a password derived key.
Okay. Yeah. I try to keep in mind who's next.
So first thing, thank you, because that's a very good, interesting tool. So thank you for this. And the other thing is, until this tool, the way I used to check the security of an email server was to rely on checktls.com, which is unfortunately not open source, but which is checking the SSL settings and the certificate chain of the email server. So it's not answering the DMARC stuff and all other email security settings. So it's partially answering to the question. And another very tricky way to do it is just to send an email from your mail server to a Gmail account and see if you have the little icon, and then you can also be sure that you have TLS enabled or not on your mail server. And then regarding the ID for the comparison, what you can also do is to save the result as a JSON file, and then just to provide an interface to compare two JSON files from a previous test and a new test, and then you can easily compare, and you don't have to save the result on your backend, but that you just need to save the result.
Just before the talk, we had the same thought internally. Thank you. We talked about what if users, because we can imagine use cases of this, where somebody creates a report and then brings this to upper management and they want to have a PDF, for example, or they don't want to look at websites. So it would be interesting to have also an export feature for PDF, or you said JSON, and then you can create your own tool based on that. That would be a good idea. Yeah, I think so too. Thanks.
Thank you very much. Fantastic work. What I was thinking now during your presentation is that email servers usually have many supportive services. For example, anti-spam engine. We know some of them are bad, some are good, some are open source, some are closed source. Some give information about the signature that they're using. The same applies for antiviruses, and you already have that information when you receive an email. So you could make a careful, for example, assessment of what kind of spam engine they're using. If they're not using, that's an issue, I believe. If anybody has set up here an email server, knows very well that not using a spam engine is like going out totally naked. You're food for the spammers. And antivirus. There are many UTM solutions that actually go in front of the email server and put a bunch of signatures. So take advantage of that by all means, but because that's email security as well.
Yeah, actually, that was also my thinking. That with SSL, I mean, well, your SSL sucks. Okay, well, that's not really the end of the world. But with email, that's a very good vector. I mean, sometimes I don't even bother doing anything, just fish in the engagements if we do red teaming. So you probably want to respond there, and then you're next.
Yeah, that's I love this feedback because that is my background is more crypto and SSL focused. So those are the ideas that we definitely need to make this really all-around perfect solution, because I would tend to always focus on the cipher stuff and so on, and those are the ideas that I like, and that's why it's so important for us to have outsiders who bring us these ideas and who want to get engaged. So thank you for the ideas.
And also that's the idea to have this discussion part. I think Klaus, you were next.
I may have missed it, but did you also check the server permission settings? Like if the mail server was open for an open mail relay?
Yeah, and I was thinking like basic stuff like I have to admit I had to run around, but something like verify, so when you can just enumerate things. I don't know if you do such a check when you just want to collect, but that's an easy check, because I mean if you allow those commands, then yeah, that's bad.
Yeah. Hello. Just I have just a few comments about the presentation. As Martin told you, the project is supported by the Ministry of Economy and Security made in LU. I represent them for the moment, and I see I'm not a tech guy, so I didn't understand all the questions, but I see that there's really an interest from you, and yes, I just like to propose that if you want to support the project, we could talk together and see the better way to involve you, to make it, to improve it, and perhaps to help to fund it. And yes, to Martin showed that the product was working at the moment and pretty well, and but there's of course possibility to add some features as we had some proposed today. And so I'd like to invite you or to talk together or to send an email to the address of the yeah.
That's the place where the suggestions can go, right?
Yeah. Okay. Indeed. Okay.
Any more questions? Yeah. If you're okay, yeah. Sorry, Mike Monkey. Here you go.
Hello. I've also been using the Check TLS website. Actually, the information there is much less granular than what you showed us. So it's very nice. On the other end, most of the, well, at least as far as I know, and I checked last time, most of the SMTP communication on the internet today is using opportunistic encryption. So basically, when you have two SMTP servers that connect to each other, they are doing a start TLS. And up to now, people find it better to actually receive email even if the TLS connection is broken. So it is nice to have the information that indeed your TLS is working fine and you have nice ciphers and whatever. But the point is, if you do a TLS strip attack and you just remove the start TLS sequence, anyway, it will bypass the encryption. So I think in the context of SMTP, at least today, knowing which ciphers you are using is not as important as on the website. And what would be really nice is to know which servers, SMTP servers, are actually checking that that they enforce the encryption. And if that would be doable, that would be nice. That would also maybe push people to decide that maybe security is better than just usability.
We cover some of those aspects. So first of all, if you send us an email, we check if that last hop comes in encrypted, and if it does not, then we flag this as a bad thing, which is something that Gmail also does. But this doesn't cover the entire chain, and that's also true. Yeah, you can just capture this one point, and that's true. But and we're also thinking about how can we, because that's another important issue. Even if the last hop is encrypted, that doesn't mean that the entire chain was encrypted. And if only one link is not encrypted, then the whole thing is moot. And yeah, we're trying to imagine ways how we could ensure, because that would be the ultimate nice thing to have. Mm-hmm. Yeah, it's hard to give a definite answer to this, but you can, at least we can try to detect some things that might point there. Another thing is, so when they send email, if we can try to connect it to their SMTP server, try to not use start TLS and to do it, and then that's a check that I've actually been working on, but it's not integrated yet. To connect to them, try to send email unencrypted and see if they accept it, because there are some configurations that would not accept behavior like this. And yeah, that's the important thing to take away here. I believe, as we saw in the discussion, everybody has good ideas that I never came up with, and so it would be so awesome for us all to work together and at least share our ideas.
All the people that have SMTP set up today, they still want to be able to receive emails from sources that do not support TLS encryption. So you need to make sure that at the point where you decide to do that, of course, you can still receive significant amount of emails, because if you do that today, I think you will block everything. And so, yeah, the initiatives like this are nice because, of course, it push people to have good configuration in the first place. And then in the future, you can indeed decide to turn it on, and that it's no longer opportunistic, but it's enforced encryption.
I think that's what SSL Labs actually has accomplished more or less for HTTPS. Because of it's a lot of people hate it because it's used for finger pointing, but also true. But I think seen as a whole, it helps to raise the bar. And like you said, once the bar is raised high enough, we can start to disable stuff that's no longer useful. So yeah, it's definitely the goal.
Time maybe for one more question, if you have it. If not, then I would like to thank you for the presentation, Martin. Give him a round of applause, please. Very, very cool project.